Dr. Hamzah Sakidin, the chairperson for this parallel session 1, PS1, for the International Conference of Fundamental and Applied Science, Icfas 2020, University Technology Petronas. So before we start for the parallel session, let's us hear welcoming remarks from Icfas Chair, Associate Professor Dr. Hanita Daud.
International Conference on Fundamental and Applied Sciences, or Icfas 2020, organized by UTP Fundamental and Applied Sciences Department with the theme of Innovative Science Towards Sustainability and Industrial Revolution 4.0, and the aims is to bring together leading experts, scientific communities, and industrialists working in the field of applied science and mathematics from all over the world to share the most recent development and cutting-edge discovery addressing sustainability and industrial revolution 4.0 in the field. We have with us three prominent plenary speakers. The first is Prof. Dr. Said Musa Negib, a prominent professor from British Kazakh University, KBTU, Kazakhstan, who will be discussing on from research ideas to commercialization. We will also have with us Yang Berbahagia Datuk Seri Dr. Muhammad Uzair Mahidin, prominent chief statistician from the Department of Statistics Malaysia, who will be talking on empowering innovation towards IR 4.0 DOSM experience. Finally, we will have with us prominent physicist Datuk Professor Dr. Haris bin Ahmad from Universiti Malaya, who will be talking about pulse generation in fiber lasers in the S-class S-band region. I am also taking this opportunity to express my sincere gratitude to all our respected plenary speakers, Prof. Dr. Said Musa Negib from British Kazakh University, Kazakhstan, Yang Berbahagia Datuk Seri Dr. Muhammad Uzair Mahidin, Chief Statistician from Department of Statistics Malaysia, and Datuk Professor Dr. Haris bin Ahmad from Universiti Malaya. Thank you all for the great support given to Icfas 2020. I also would like to convey my sincere appreciation to all delegates for supporting Icfas 2020. Our delegate among all are from Malaysia, Kazakhstan, Indonesia, Vietnam, Pakistan, and Nigeria, and will be sharing their expertise in the area of sustainable chemistry, nano and sustainable technology, mathematical and analytical methods in science and technology. Last but not least, I would like also to convey my sincere appreciation to the organizing committee for Icfas 2020 and ISCON 2020 main committee for working so hard to make this conference become reality. Dear delegates, please explore our conferences. Among others are having the following features in the virtual ISCON 2020, such as virtual exhibition booth and interaction with exhibitors. And we also have resource gallery. You may download all the materials that have been uploaded. You may also go for virtual tour so that you get to know UTP better. We have also live support. Feel free to ask and seek clarification. And finally, we have also gamification. Be proactive, especially to gain more points. I hope this conference, all of you will be able to forge connection, strengthen network, gain benefit from the conference, and be part of one of the largest conference in the world and have an enriching, edifying time in ESCON 2020. Thank you.
Yes, thank you, AP Dr. Anita Daud. Okay, now the flow, I just want to give the flow of this presentation session. So the first one, it will be introduction of the presenter. I will introduce the presenter, and then the second one, the video recording from presenter will be played, and the third one followed by a 5 minutes Q&A session, okay, for each presenter. Okay, let us start with the video recording from the first presenter. I think before that, I would like to introduce the first presenter, which is Prof. Dr. Mawardi Bahri from Hasanuddin University, Indonesia. The title of his presentation is Some Properties of Fractional Wavelet Transform and its Relation to Conventional Wavelet Transform. Is Dr. Prof. Mawardi here? Okay, maybe Prof. Mawardi is not here. So I think we can proceed to the next presenter, the second presenter, Nguyen Tien from FPT University, Vietnam. The title of the presentation is Monotonicity Preserving Interpolation Using Rational Quartic Sideball Function. However, this presentation will be presented by Dr. Samsul Arifin.
Assalamualaikum and very good evening. I'm Samsul Arifin by Abdul Karim. We're presenting a paper entitled Monotonicity Preserving Interpolation using Rational Quartic Sideball Function, in which joint work with my colleague in FPT Vietnam, Tuan Tien Nguyen. So this is definitions. So this is introduction. So what's the data interpolation? Actually, data interpolation or data approximations are very important in science and engineering application. For instance, if the data maybe not a big data, so interpolation would be very useful. If the data is really big data, for instance, so approximation much more better lah, because the more the data, if interpolate, let's say we have 20,000 data sets. So we need to interpolate all those 20,000. So it's comparing with approximation, we may use any regression technique. We are subject to certain conditions, something like that. So in the study, we focus on data interpolation, in which we try to preserve the geometric properties of the data. For instance, geometric properties are monotonicity, convexity, and positivity. So in the study, we cover monotonicity. We discuss monotonicity, in which we extend one and 10 words. However, in our study, we employ a different rational spline compared with the original work by 1 and 10. So actually, it is based on sideball basis functions. Okay, so this is the definition, rational quartic sideball interpolants. So we define like this. So Pi, Qi is given by these functions. Okay, so Qi, this is what we call linear function. So this is another form we call 4/1. 4/1. This one to ensure rational quartic. So it is satisfied these four conditions. So we call it C1 conditions. So in which they are known, so can be derived like this now. So the I are the first derivative. So the given rational quartic will be C1 along this interval. So meaning that it is C1 everywhere. So what happens if alpha equal to 1? So if alpha equal to 1, it will reduce to non-rational quartic, which is polynomial quartic sideball, in which in general it's not shape preserving. So this is monotonicity. So monotonicity, this is the condition. However, in our study, actually, we consider strictly monotonicity. So this is the condition in which gradient must be positive or equal to 0. And the derivative also must be positive or equal to 0. Otherwise, it is not monotonic. We describe monotonic decreasing. Another counterpart is monotonic decreasing. That one different story. So we need to derive first derivative. So after simplification, we obtain this one. And we obtain this condition. This is condition for monotonicity subject to the derivative constraint. So here we have, so we propose one proposition in which we simplify the given into this form. So we obtain this diagram. So meaning that the shaded one is monotonicity preserving. So the derivative must satisfy this condition given like that. So one question is how do we choose that derivative? Because derivative must satisfy. So in this study we employ we call Butler technique. So we employ these conditions and we employ this condition for the endpoints, okay, and this condition for the in between from I2 until n-1. So we employ this technique. This is we employ what we call Butler and Priest. Okay. So this is algorithm. So we input the data, right? We calculate everything. So this is the algorithm, and finally we generate the monotonic interpolating curve, which is monotone everywhere. So this is example result and discussion. So this is the data set. This is simple example. So this is the default, which is alpha equal to 1. So it is not monotone. So we can see here it's not monotone. Okay, data is monotone, so this curve is not monotone because it is turning down there. So this is what after we apply our proposed technique, we manipulate the alpha, so we obtain the full shape. This is the nice shape preserving monotonicity shape preserving with different alpha. You see, we manipulate a bit. And this is different technique from Sapras. So actually our proposed technique, Sapras here could be over cubic. Ours on the quartic over linear. So looks competent with existing technique. So this is conclusion. This paper actually has proposed a new shape preserving interaction as a rational quartic set ball, quartic numerator and linear denominator with one shape parameter. So we only have one parameter, but that parameter can be used to alter the shape. So the sufficient condition also has been derived. So we are able to derive that monotonicity condition. So meaning that if monotonicity condition is met, then we obtain shape preserving, which is monotonicity or monotonic interpolated curve. Is not met, then we need to modify the derivative. Otherwise, it is not we call not monotonicity preserving, something like that. So our method, we believe, require less computations. It is local. It also gives result. Of course, because let's say cubic over cubic, confirm require more calculation compared quartic over linear. Like that, right? Cubic is become degree 6. Quartic linear become degree 5, something like that. So actually, we also in the process to complete the study more general. We try to cover, let's say, positivity, complexity, and constraint modeling. So this is acknowledgement. This study is fully supported by Ministry of Examination and Institute of Petronas through FRGS research grant. This is some references. So the method we call is Priest and Butler. This one we employed the technique to find that derivative. So the others can refer. This is classic, right? But this is what we call the main references up to now. Even though it's classic, because we need to determine the estimate the derivative, we must refer to Tabago and Gregory. Even though 1985, but up to the researchers still use the article in order to estimate the derivative. So this is some references. You see, most are the previous one, but still valid up until today. This one my article, then you can refer yours. Okay, so I believe I finished my presentation. Thank you very much. And if you have any question, you can let me know. Inshallah, I will try to answer my best. Okay, thank you.
Now we can start with the Q&A session. So for those who want to ask the questions, please write your question using live Q&A button below. You can see on the screen below the live Q&A button. So if you have the question, and then after you write the question, I will read the question, and then the presenter will answer it verbally. So any question from the audience? So far no question, maybe not yet. So no question. If no question, maybe you can end the session for Dr. Samsul just now. We can go to the next presenter. Thank you, Dr. Samsul. Okay, for the next presenter, Ms. Labiana Hanif Ali from University Malaysia Sabah. Okay, the title of her presentation is Application of Newton GS Iterative Method with Second Order Quadrature Scheme in Solving Nonlinear Fredholm Integral Equations.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. I'm Labiana Ali from University Malaysia Sabah. For this conference, I would like to present application of Newton GS iterative method with second order quadrature scheme in solving nonlinear Fredholm integral equations. Here are the content of this presentation from introduction to the references part. For introduction, given here are the general equations of nonlinear Fredholm integral equations of the second kind, where ft and kernel is the known function and ut is unknown function which need to be determined. This problem has been solved by using so many analytical and numerical methods, such as stated here. However, due to its significant contribution in mathematics, physics, and engineering, the studies on solving this problem is continued until now. Inspired by the accuracy of the data through the implementation of higher order quadrature scheme, this study proposed Newton-Jacobi and Newton-Gauss-Seidel with second order quadrature scheme to solve this problem. Since one of the advantages of second order quadrature scheme in comparison with the first order is that it can provide more accurate approximate solution. Subsequently, the application of Newton-Jacobi and Newton-Gauss-Seidel with Simpson's 1/3 is expected to give more accurate result. The methodology of this study is designed by two main parts. In the first part, we discretize the problem using the first and second order quadrature scheme in order to generate nonlinear system. And then in the second part, we use the Newton iterative method to solve the nonlinear system to get the approximate solution for the given problem. Here, NJCT and GSCT represent Newton-Jacobi and Newton-Gauss-Seidel using composite trapezium, which used as control method in order to validate or illustrate the effectiveness of the proposed method. Newton JCS1 and Newton GSS1 here represent Newton-Jacobi and Newton-Gauss-Seidel using composite Simpson's 1/3. The formulation of quadrature scheme to discretize the equation 1 is given in equation 2, where numerical coefficient Aj for trapezium and Simpson's 1/3 can be given in equation 3 and 4 respectively. This figure shows the comparison of finite grid networks for trapezium and Simpson's 1/3 on interval AB. As we can see here, the implementation of Simpson's 1/3 will consider more node points on interval AB compared to the trapezium rule. This will help to reduce the neighborhood distance of each node point on interval AB, which resulting more accurate approximate solution. From the discretization of equation 1, we can have the following approximation equation. This equation can easily be specified by replacing the AJ using equation 3 and 4 for trapezium and Simpson's 1 over 3 respectively. Then we can generate the nonlinear function of this equation can be represented as in equation 6. Thus, we can have the following nonlinear system. Using Newton's method, we linearize this nonlinear system into a linear form using the Jacobian matrix. To solve this nonlinear system, we have to decompose the Jacobian matrix into D minus L minus U, where D is diagonal matrix, L is strictly lower triangular matrix, and U is strictly upper triangular matrix. So that we can have the following formulation of Gauss-Seidel to solve the linear system as in equation 10. For section 3, here we present 3 numerical examples which considered in this study. Table 1 here shows the numerical result of Newton-Jacobi and Newton-GS iterative methods using trapezium and Simpson's 1 over 3 for example 1. This study considers 5 mesh size from 512 to 8192, and we also use 3 measuring parameters, which are number of iteration time, and maximum absolute error, to do the comparative analysis between the tested method. From this data, we found that there are not much difference between Newton-J and Newton-GS for composite trapezium and composite Simpson's 1 over 3 for number of iteration and iteration time. However, in terms of maximum absolute error, this study found that the implementation of Newton-Jacobi and Newton-GS using composite Simpson's 1 over 3 recorded more accurate result compared to the method with composite trapezium. Similarly, for example 2, Newton-Jacobi and Newton-GS with composite Simpson's 1 over 3 have recorded more accurate result. And also for example 3. In this figure, we illustrate the data just now in the graphical form. As we can see here, it is clearly that Newton-GS CS1 have recorded more accurate result compared to the rest tested method for example 1. Similarly, for example 2 and example 3. This is due to the implementation of second-order quadrature scheme, which help to reduce the neighborhood distance between each node point on integral AV, which then help to provide more accurate result for the problem of nonlinear Fredholm integral equations of the second kind. For the conclusion, the implementation of second-order quadrature scheme can improve the accuracy of the output compared to the first-order quadrature scheme, and we conclude that Newton Gauss-Seidel with composite Simpson's 1 over 3 to be the most efficient method in solving nonlinear Fredholm integral equations of the second kind compared to the rest tested methods in this study. For the future study, this finding could be extended using the combination of half-sweep iteration concept together with vector parameter iteration family, specifically to vector parameter, modified vector parameter, and accelerated parameter iteration families to provide method with the best to provide more efficient method in solving nonlinear Fredholm integral equations of the second kind. For acknowledgement, all authors would like to thank University Malaysia Sabah for funding this research under UMS Research Grant Scheme. Okay. Lastly, here are the list of references used in this presentation. That's all from me. Thank you.
Thank you, Ms. Labiana Hanif Ali from UMS Sabah. So now we can start with Q&A session. So for those who want to ask the question, please write your question using live chat, live Q&A button below. Okay. Any question from the floor, from the audience? Okay, I think if no question, I want to ask one question. Regarding for this paper, what is your main contribution for this paper? Can you explain the main contribution for this paper? Can you hear me? Yeah, Miss Labiana, what is the main contribution for this paper? Because I can't hear you. Okay, there's now one question for me. What's the main contribution in this paper? And then the second question from Dr. Samsul Arifin. How does the conversion of the scheme? Okay, there are two questions. I can't hear you. Any? Yeah, Miss Labiana, please join the green room. Maybe you're not in the green room because I cannot see your face on the screen. You can click the button below on the left side. But okay, you have joined the green room, but I cannot see your face here. Because your face is not still not on in the green room. Okay, I think there is a maybe technical problem here. So okay, maybe you can keep both question for at the last of this session lah. Okay. Maybe after the last presenter you can join back lah. Then to give your answer, or at least you can write down your answer on the screen. Okay. Okay, I think we can proceed to the next presenter. Maybe you can hold on for the Miss Labiana. Okay, we can proceed to the next presenter. Our next presenter here is Dr. Samsul Arifin Abdul Karim from UTP. The title of presentation is Positivity Preserving Using C-squared Rational Quartic Spline Interpolation. Okay.
Assalamualaikum and very good evening. I'm Samsul Arifin bin Abdul Karim. So I will be presenting a paper entitled Positivity Preserving Using C2 Rational Quartic Spline. This is joint work with my former student Nur Adillah Harib from City Project Petronas. So this is all of the presentation, abstract, introduction, rational quartic spline, and we discuss positivity preserving interpolation, numerical examples, and later we cover conclusions. So this is the abstract. So this is the introduction. Actually, what's the shape preserving? Shape preserving means, let's say we are given data set, then we want to interpolate all those data set by using certain technique. So let's say we apply spline interpolation, for instance. So that spline interpolation must be able to produce an interpolated curve which are positive everywhere. So meaning that there must be non-negative along the whole intervals, something like that. So what's the positive? Actually, many real application are positive. For instance, maybe gas discharge during experiment, which is positive. Probability distribution also always positive. Rainfall distribution also always positive. Actually, there are gaps between the existing schemes in which we found that local control for C2. So this is the microrational quartic spline in which we taking numerator are degree 4 and denominator are degree 3, degree 2, sorry. So we have 4 over 2. So there are 3 shape parameters, which is alpha, beta, and gamma. So this is condition for C2. The first two are C0 or C0. The next two C1, and the last one is we call C2. So our rational quartic spline defined here must fulfill all this requirement in order to become C2. Why C2? C2 is more smooth compared to C1 because it's second order. So after we impose that C2 condition, this one, so we obtain this simple. This not simple actually. They are lengthy with derivation. After simplification, we obtain equation number 5. So now we go to positivity preserving interpolation. So let's see we are given this data as a Fi from I1 until n. So in which n must be increasing order as 1 less than. So we only consider strictly positive data set. Why non-strictly? Strictly must be greater than 0. If not strictly, 0 must be included. We see later why we cannot we cannot have non strictly lah. So usually the rational must be usually it is strictly positive. So actually this function is already published in few articles from the Harim. Okay, so this is the main result, which is given by theorem number 1. For strictly positive data set, the rational quantity plan defined on the interval is positive in each subintervals if the following sufficient conditions are satisfied. So this is why, okay, this is why we impose that strictly, because this one, if equal to 0, so it is undefined lah, right, divided by 0. This is the main reason lah. The main reason. So this is the main reason lah. We talking about strictly positive. Okay, so we test the proposed technique by different data sets. So here we just discuss one. So this is endpoint. This is endpoint. This is endpoint. So at endpoint, derivative are same. That's why we refer here derivative are same. This one same. This one also same lah. Except in the middle lah, right? 2 and 3. So will be different lah. This is our proposed technique lah. So this is curve. This is from Hussein. This is from Abbas. All C2 this one C2. So we comparing with C2 lah. This is also C2. And this is Karimcom. This is also C2. We compare with different technique. This is quartic. Quartic means default. Default means alpha, beta equal 1 and gamma equal 2. So this is not positivity lah, because we can see here there are some part are negative lah. This part negative. Actually this part also a bit negative, so we can improve that one. So we see here. Okay, so if we compare between E and F, F is really smooth lah. Really smooth, is positive, is C2. So what happened to this Hussein? So if we refer here Hussein and all technique is not positive everywhere, because if we draw straight line, there's some part are negative here. Some part are less than 0, which is negative result for Hussein and all technique. This one negative result. This one. So if we draw straight like that, so here part negative, which is cannot be accepted. Cannot be accepted. Okay, so this is conclusion. So we discuss, we propose a new rational quantity plan with C2 continuity, and later we derive positivity, shape preserving interpolation condition, right? So the main advantages our technique is, in order to achieve C2, we do not require to solve system linear equation. Usually, let's say for instance cubic spline is C2 also, but we require to solve trigonal system linear equation in order to calculate that first derivative. But we see our technique is that it's not needed. We just, how do we find the derivative? Actually, we apply equation number 5. This one. So derivative here lah. This di there. Di there. Actually, we can simplify lah. We may simplify equation number 5 to find the di. So more result can be obtained from our article. So we just discuss a basic thing, and as well as how do we implement the proposed technique in order to achieve C2, as well as shape preserving positivity interpolation. So the two free parameter can be used to manipulate. Actually, we manipulate until we achieve the best interpolating curve here lah. We manipulate that value. So at the moment we yet to have what we call automatic. This is still automatic because that's free parameter we can manipulate, but we can embed any machine learning technique in order to find the optimum value. That one may be for future studies. Okay, we also found that our scheme is positivity preserving interpolation everywhere. Meanwhile, the work from Hussein et al. Is not positive everywhere, because on some interval it is produce the interpolated curve produce negative value, which is negative value means that, let's say we have a axis like this, right? So maybe some part curve is below a axis, so this one unacceptable because the given data is positive, but our technique confirm positive. This is acknowledgement. So thank you to Ministry of Education Malaysia, MCT Petronas, for the financial support received in the form of research grant FRGS. So this is FRGS. So I finished my presentation. Thank you very much for your time. If you have any question, you can direct to me. Thank you very much.
Good. Thank you very much, Dr. Samsul. Okay, for the presentation. So now we can go to the Q&A session. So the attendees or the participant can write the question in the live chat Q&A, and also you can use also the discussion forum. Okay. So any question from the audience? You can type it in the discussion forum also, or in the live Q&A. Okay, one question from me, Dr. Samsul. Just want to know what type of method that you use to verify your answer or your result.
What apa? What method?
Uh, how you want
Oh,
to verify,
uh,
your results.
so it's depend to theorem number one lah. Right, theorem number one, right? So that actually there are three parameters, alpha, beta, gamma. So the sufficient condition are derived on gamma lah. So meaning that alpha, beta will be free parameters. So meaning that we writing coding lah. We writing coding, we find the gamma for each intervals. So meaning that after we impose that theorem number one, so it's automatically satisfy positivity for each interval. So meaning that let's say we have 10 data set, right? So we have 9 interval lah. So meaning that we calculate the gamma for each interval. Interval number one, that's we have gamma value. Number two, different value for instance. Until we achieve that 9 interval lah, then we combine all those things, coding, then we generate that curve lah. So it is confirmed positive lah based on that theorem. So that's how do we validate lah. But for the example, we use scalar data set. Scalar data set meaning that we cannot calculate any error lah, because it is not the data is not coming from function, right? So different our different article just now we consider data from a function, then we can calculate the error lah, something like that. For the example, we cannot do other than that one lah. So usually because it is scalar data set, so usually we use what we call visualization lah. We just visualize something like that, whether it is positive on like for instance Hussein, right? So some part are negative, so we can validate that one lah by zooming that part, something like that, because it's scalar data set. Unless from function, then we can calculate the error. So scalar data set, we cannot calculate error lah. Like that lah. That my answer lah.
Okay. Okay, thank you very much, Dr. Samsul.
Okay, welcome.
Okay. So any more questions from the others, from the participants? Okay. So if no more question, I think we can proceed to the next presenter. Okay. Our next presenter is Mrs. Amiratul Liana Muhammad Hanafi from UTP. The title of her presentation is A Comparison Study on Developed FSWGARCH and GARC Model in Time Series Forecasting and Application to Airline Passenger Volume. Okay.
Assalamualaikum and good day. I am Amira Tuliana from University Technology Petronas. Today I would like to present my study entitled A Comparison Study on Developed FSW GARCH, SW GARCH and GARCH Models in Time Series Forecasting and Application to Airline Passenger Volume. Okay, for the outline of my presentation today is firstly introduction, secondly methodology, thirdly data analysis and results, and finally conclusion. Okay, so first let's go to the introduction first. Okay, airline passenger volume keeps increasing significantly each year. The airline passenger data engage in some seasonal periodicity with an upward trend, making the data non-stationary and non-linear. Therefore, it is crucial that this airline passenger volume to get forecast accurately to handle the non-linearity of data. The most common model for analyzing non-linear time series data is Gauge model. Gauge model uses long-run average variance. However, it does not capture the influence of each variance in the observations. Thus, in 2017, an improved sliding window gauge model was introduced to overcome the weakness of gauge model. SW gauge uses window variance to determine the forecast weight based on the principal component. However, the principal component is prone to error because the original features of the dataset is a linear combination. As a result, some information is missing as well as not readable and interpreted in comparison to the original list of features. Okay, therefore, this study aims to address this drawback by proposing fuzzy sliding window gauge for time series forecasting model. This FSW gauge impose fuzzy window variance which automatically replace the long-run average variance in gauge model. The applications of fuzzy is important to deal with the uncertainties data, and also to fuzzy is robust to noise data points and offers positive forecast results even in cases where the number of observations entails uncertainties. Okay, next we proceed to the methodology. Okay, firstly, I would like to show you the gauge model. The gauge model is represented as below. This is the equation of gauge. Okay, the VL is the long run average variance. So here is where we this is where we enhance the model to reduce the errors. So the second model is sliding window gauge model. Okay, the sliding window gauge replace the component of long run average variance into the component of window variance. So this is the SW gauge model. So here is the long run average variance is replaced by window variance. So this window variance is calculated from a sliding window technique based on PCA. Okay. Next, we propose fuzzy sliding window gauge model, and we replace the long run average variance with fuzzy window variance. So fuzzy window variance is computed using fuzzy sliding window algorithm, which is developed based on fuzzy logic and sliding window knowledge. Okay, this is the fuzzy window gauge, and here is where the enhanced involved. The long run average variance is replaced with fuzzy window variance. Okay, let's see what is the fuzzy sliding window algorithm. There are 5 steps involved. First is we load and fuzzify data into triangular fuzzy number. This is the definition. And then we divide the data into a matrix of current year and a matrix of previous year that consisting of 24 months from the preceding 2 years. So this is the sequence of the matrices. And then we construct 12 sliding windows defined as X from the previous year, and then we calculate the difference between the current values in Y and the previous values in each X. So here is the calculation for the difference, and then finally we find the Euclidean distance of each difference, and then we compare the Euclidean distance of the 12 sliding windows. And then the minimum mean of Euclidean distance estimates the size of window, thus determines the weight of forecast. Okay, this is how we calculate the Euclidean distance. Okay, next we proceed to the model validation. Okay, for model validation we use root mean square error and mean absolute percentage error. Okay, Noted here, according to previous study, if the proposed model produces smaller value of RMSE and MAPE than the benchmark models, it is interpreted as producing higher accuracy of forecast, thus becoming a better model. Okay. Now we proceed to the data analysis and results. Okay, we use the airline passenger volume. This figure 1 shows the part of monthly USA airline passenger volume. So from this figure, there is increasing trend and cyclical component in this figure, right? Thus, it indicates that the necessity of suitable model for nonlinear forecasting. Okay, let's do the forecast. Here is the forecasting for performance. Okay, the proposed model is compared to the benchmark models of SW-GASH and GASH model. Okay, table 1 shows the comparison results, and this is the actual value of the data, and then this is the forecasted value of FSW-GASH, SW-GASH and GASH models. Okay, figure 2 plot the actual data versus the forecasted values using the three models. Okay, you can see here that the orange line, the proposed model, is the nearest to the actual line, which is blue color. Okay, to easily see the difference and compare the result, let's see the RMSE and MAPE produced by the proposed and the benchmark models. Okay, this is table 2, present the comparison results of RMSE and MAPE. Okay, we can see from here FSW-GASH produced 2.02 and power 5 for RMSE and 1.2447 for MAPE. So we compare here, we found that the FSW-GASH produces the smallest mean of error of RMSE and MAPE compared to SW-GASH and GASH. So this means that the proposed model is able to reduce forecasting errors and outperforms the benchmark models in forecasting the airline passenger volume. Okay, in conclusion, the enhanced model implemented a component called fuzzy window variance to replace the long-run average variance component in the GASH model. Okay, the fuzzy window variance in the combination is the combination of fuzzy theory and study window method. Okay, based on the results, by producing lower mean errors, the FSW-GASH model produced higher accuracy and outperformed the other models. The findings have shown that the proposed model is superior and well adapted to forecast time series data. And the fuzzy study window GASH model is capable of capturing the influence of variance in each observation and can identify the true window selection for forecast weight. The true identification of forecast weight yields the best performance in accuracy. Thank you.
Now we can go to the Q&A session for Amira Tuliana. So just now I already have some questions from Dr. Samsul, but I think Ms. Amira Tuliana already answered the question. I think it's okay if you Amira Tuliana can read the question and give the answer.
Okay. Okay, first question is how fuzziness are the data sets. Okay, before we analyze the data, we observe the data from the prior data sets, and we see the fluctuation of the data. And then this fluctuation means that there are variances, there are effects in positive and negative effects of the data sets. means that increase and decreases. So it means fuzzy there, increasing and decreasing trending. Okay, second question is how the results compare with other forecasting technology. Okay, based on this paper, I compare with the mean square error and mean percentage error. So, based on paper Kapila et al., it says when the error of the new method or new model using new model is lower than the previous or the benchmark model, then it is a better model. So from here I compare with Gush because the new one is fuzzy sliding window Gush. So I compare with Gush and SW Gush. So it gets better performance than the benchmark model. And then the third question, what is new about the proposed fuzzy method? The new is previous method use Gush only. It is the base, the main reference model. And then second model is sliding window Gush model. The sliding window Gush model use principal component analysis to measure the forecast weight. For my method, I use sliding window but in fuzzy numbers. It is very different. In fuzzy numbers, we compare which windows uh, which windows create the smallest forecast weight so that it produce smaller error. Do you understand? So that it is named as fuzzy sliding window, and we combine with Gush. Am I answering the question? Question number one: fuzziness of a data sets. Um, uh, uh, Okay, the fuzziness of data sets, it is actually a value of a time series. Time series have one value, right? It is a crisp value. And then, okay, I make it into fuzzy number. I make it into a triangular fuzzy data. From there, I transform. Yes, the answer is I transform the time series data into triangular fuzzy data. From there, we got the fuzzy data set. I first transform the data.
Okay, is it answer your question, Dr. Samsul, is now? For number one? Maybe if you need more clarification from Amiratul.
Okay.
Is it okay, Dr.
Oh,
Samsul?
maybe.
Okay, I think it should be okay if there's no response from Dr. Samsul. Maybe any other questions to be asked to Amiratul? We still have time. Okay, I think if no question, thank you
Okay.
very much, Amiratuliana,
Thank
for
you
your
very much.
presentation. Okay, so you are the last presenter for today's session for this time.
Okay.
Now we can go back to the second presenter just now, Miss Labiana Hanif Ali. For there are two questions. So okay, I think maybe you can refer back to the question, Labiana, and also you can give the answer.
Assalamualaikum, Doctor. Can you hear me?
Yeah, can. Proceed.
Okay. For the first question, what is the main contribution of my paper? Actually, it is clear on the title that we propose the Newton GS iterative method with second order quadratic scheme to solve the nonlinear Fredholm integral equations of the second type. So when we use this combination, we can solve the problem more effectively by just require more by just require small minimum number of iteration time, and by using quadrature scheme we can get more accurate result. Because based on the previous study, the main contribution of their study is they want to get the more accurate approximate solution for nonlinear Fredholm integral equations. So when we compare the first and second order quadrature scheme, second order quadrature scheme can give us more accurate result. So this combination is more effective to solve the problem. Okay,
Okay.
Data?
Okay, thank you for the first question. How about the second question?
Yes, for the second question, how does the conversion of this scheme? Actually, for this paper, we have not included the convergence analysis, but we will consider to include the convergence analysis on the next publication, because it is sufficient if we just compare the new method with the existing method, and with a new contribution. Okay.
Okay, just now, Dr. Samsul, is it okay for the answer from Labiana?
Boleh dengar tak?
Okay, can.
Okay, Labena. Okay, my last question for today. Okay. Okay, you are using quadratic spline, isn't it? Am I right?
Quadratic,
You are using quadratic spline, correct?
the quadratic schemes doctor.
Quadratic scheme. Okay. So how does is compare? Let's say you applying cubic scheme, for instance. So in your opinion lah, right? So which one much more better?
Cubic, we
Ah,
we have not yet we have not tested for cubic on this
ah,
problem yet, doctor.
try lah.
Yes. Okay,
So
I will
okay,
consider.
okay.
Yes,
Thank you,
doctor.
thank you. Okay,
Thank you,
okay.
Okay.
Salam
doctor.
kat Dr. Jumaid. Okay, okay,
Ya, terima kasih, doctor.
okay, okay.
Okay, there's a suggestion from Dr. Samsul, Labiana. Okay,
Ya,
maybe
doctor.
are you
Betul.
a PhD course student or master student?
PhD student, doctor.
Okay. This is part of your research lah, right?
Yes, doctor.
Oh,
The initial finding.
okay.
Okay.
Okay, so thank you very much, Labiana,
Thank you, doctor.
for the question. Any other question? Maybe last question for Labiana before we stop for this session from the audience.
Okay, I have final question.
Okay.
What's the optimum H?
Doctor,
What's the optimum H? Step size itu. What's the optimum number then? Optimum choice lah.
we just use the just now I have given the formulation for H in equation 3 and 4. So we actually just use H as the equation equal to B minus A over N. So we actually just manipulate the N number. So if we set the N number to 256, so the grid size will be depends on that.
So coding is writing using what? C++ or MATLAB or Fortran?
Boolean C++, doctor,
Oh, C++
using
lah.
C
Okay.
language. Yes.
Okay. Okay. Thank you. Okay, good luck.
Thank you, doctor.
Okay, thank you, Dr. Samsul. So maybe if okay, I open to the last question. One more before we stop. Any more question? Okay, I think because it should be we should have 6 presenters, but now we only have 4 presenters, and then 2 who is not appear here today. So that I think I would like to thank to all the presenters and also the participants for attending this session and also for the Q&A session just now. Thank you very much for your participation. Okay, so I think we can end the session. Thank you very much. Okay, thank you.